Hello everyone, welcome back to my channel. And in this video we will be learning how to design an e-commerce web application using a Node JS backend. So I'm going to implement a microservices for designing this application. For example, I'm just going to create a 6 microservices for this application, and you can build each and every services in a language that is more convenient. For example, you can build this odd service in Java and this product service in JavaScript and this card service in Python, like that. uh, you can design your system accordingly. So but right now I'm going to design only using a Node.js. So how this works is, this is a front end, the client is a front end, and it communicates to each and every services through this API gateway. So it acts as a single entry point for our application, and this is a registry, and each and every service will register to this gateway API gateway service, and the client will talk only to this API gateway. So behind the scenes, it does all the routing. For example, if you wanted to use a hot service, just route through this API gateway. So now I will be talking about the tech stack I'm going to use, and for creating this API gateway and the service discovery part, I am going to use this console dashboard. So it's a free tier application. You can make use of this console for service discovery. So what I mean by service discovery is, if each and every services has to talk to each other. For example, this card service and inventory service has to talk to each other. Uh, then there has to be a mechanism for this service to communicate, right? So it may not be a single static IP address. For example, you are hosting it in a AWS service. Take example of AWS service, and if that IP address keeps changing, or sometimes even you don't have this, uh, it keeps dynamically changing. It is not only static. So in that case, the service discovery will be super helpful. Since you are registering under this console dashboard, you just you just discover your services through the service name and not through the IP address. And also, since I am going to make use of a Docker Compose, uh, firstly I will talk about this Docker. What it does is, it just containerize your application into a small part, and each and every services will be hoisted to the will be published to the Docker registry, and from there you can pull your images. And for you need not start each and every services individually. So using a Docker Compose, you can just orchestrate all your services under a single network, and just you can just make use of a single Docker Compose up command to up all the services, and also keep track of the services that are failing. So I'll be just showing you the code shortly how I'm going to do that. And also I will be making use of this load balancer. And this load balancer, what it does is, it just uses a round robin technique. And for instance, I will be creating a 3 instances for this product service. So if there is more traffic at a peak time, for example, take example of a festival season, a Black Friday or a Christmas season. So during those times, more customers will visit your website to purchase the products. So during that time, if you just increases the traffic to single server, then your application may possibly be crashing, right? So for that, I am making use of this load balancer to route the traffic to each and every instances that are created. And uh, and also, one of the major use of this microservices is, if one microservices breaks, then we can add a fallback mechanism in such a way that our entire application won't be crashing. So that is a major use of this microservices, and you can make use of this various languages and framework using this microservices. And it's not tightly coupled; it's also very loosely coupled. So that's a major use of this microservices. And now I will be showing you how I have designed this. For example, so these each and every microservices has a Docker file in it, and I will be creating an image out of it. And I have a specific playlist for this how to create this Docker images for the Node.js application. You can watch those files. And since this each and every microservices has this Docker file, and it can run on their own container. So you see that this service will be running on different ports. And I have a Docker compose file. So since I have this individual Docker file in each and every services, I have pushed to the Docker registry, and this is my Docker registry, and I kept it public so that anybody across the globe can pull the images and can use the images and run it as a container, right? So you can see that in the Docker compose, this is a container orchestration, and I have made use of the services, and I have grouped all the services. So these many services I have created, and I have grouped all the services under one network so that they can communicate to each other easily, and there won't be any problem in this communication if you are grouping this under a single network. So this is about the Docker Compose part, and I have already discussed about the API gateway, right? So it acts as a single entry point for our client to interact with. So I have created a console. I have registered all the services under a console. So you can see that I have made use of this Express.js to create my Node.js application, which is this Express.js is a Node.js framework for creating our application. So in the API gateway, you can see that if I use slash API and then the name of the service name, and then it can be any path, then I will be routing to the specific services that are registered under this console dashboard. And then each and every services talk to each other. For example, I have already shown you that this card services talks with inventory services, right? It's a synchronous call. It's a simple REST API call. So how they communicate is, this is something interesting. I will just be going to the card service to show you that thing. So if you come to this card service, it has this card route. So once the user has added to the cart, it will be coming to order service. You can see uh, Actually, I have explained this diagram wrongly. It should be the order service should be talking with the inventory service. So you can see that it is already registered under this console dashboard. I'm registering the service. So if if one service has to talk to each other, it can either be a synchronous API call or an asynchronous process. Right now, since my inventory service is also registered under this console dashboard, I just use this inventory URL. This inventory URL is this is the service discovery part, and this console dashboard will internally check for this IP address, and then this is the route I have used. So this is how this communication happens between the services. And now I will be showing you how to up all these services using a single Docker up command. All you need to do is just have to run a single command. This is the command I'm going to use. Now Docker compose up and build. This is the specific command, but since I have used a load balancer, so I am just additionally using this extra attribute to scale my services, just to show you how this load balancer works. And when the services is up, I will be showing you the console dashboard how this is going to work. You can see that it is dynamically pulling the image from the Docker registry, Docker Hub registry, and each and every services will be registered under this. And you can also perform a health check. And right now, I will be using console. Console will be running on localhost 8500. So this is my services. I have already told you that I have these many services, and each and every services has this own image, and I am pulling this image from the Docker Hub. And you can see that this product service alone has three instances. Why that is? Because we have used the scale command to scale my service, right? So hence three instances is created, and you can just navigate to this hot service, and it is running on this localhost 3001. And you can see that it's not displaying its IP address, it's just displaying the registry name. And this is the registry name I have used, service name I have used while registering the service. And to check whether my application is running or not, so each and every is running on a different board, but I am making use of this API gateway. Yeah, you can see that uh, in all the services I will be making use of this single entry point, that is 3000 localhost port. Still it will work. So that is the main use case of this API gateway. You can see that I have logged in, and once I have logged in, I will be searching for the services. You can see that since I have placed this load balancer in my product service, you can check this instances. It's 767, right? If you just go to this product service dashboard 767, so the very first time when you hit, it will be routing to this thing, and on the second time the traffic moves to the next thing. So this is a round robin technique, which means that there are three instances. The first time it will just route to this one, two, three. In an order it will be routing, that is round robin technique, the load balancer. Again it just route back to 767, 9CD, and F4C8. So this order services talks to this inventory service, right? So behind the scenes, those things happens, but when you just hit this order service, you can see that this order service internally does this thing. It will talk to the service and check whether whether the stock is available or not. If the stock is not available, then it will just throw an error that is stock is not available like that. Now I will be just giving a random product ID. So it says that item is out of stock. So this way the services talks with each other. And if something fails in any other services, it will be logged to this Docker compose up command. So this way you can keep track of your logging. So this is how microservices talk with each other. And if you want a more detailed video of it, just comment it down. I will just make a detailed video uh, from the scratch. So that's it from my end, and thank you for watching. Thank you.